What I mean by fatty acid is that you've got this long zigzag chain of carbons and hydrogens. This zigzag is simply line angle formula showing here is a carbon. It needs 4 groups, so there's 2 hydrogens. This carbon, 2 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens. So everywhere you see this vertex, that just represents a C, a carbon atom. Everywhere you have a C, it needs 4 bonds, so it's just CH2, CH2, CH2. And this last carbon needs 4 bonds, so it's CH3. So all of this is one big hydrocarbon, carbons and hydrogens, that is very hydrophobic. Hydrophobic just means doesn't like water. It's fatty. It will repel water. It will not dissolve easily in water. In chemistry, we call that non-polar. Carbons and hydrogens have similar electronegativity, so you don't have a region of negative or positive anywhere along this long hydrocarbon chain. It is non-polar. It's going to be fat soluble. So this is the fatty part of this acid chain. So this is a common functional group, a carbonyl, a C double bonded to an O, bonded to a hydroxyl, an OH, makes up the functional group a carboxylic acid. So this is a carboxylic acid group bonded to a long hydrocarbon chain. We call this top chain saturated because there are no double or triple bonds. It contains as many hydrogens as are possible for these carbons on this long fatty acid chain. The molecule is a saturated fatty acid. It will clog your arteries. It is not going to be very soluble in water. It's going to form a plaque that will attract other plaque type molecules, and it's not good when taken in excess. Here, this other type of fatty acid molecule, you'll see it's unsaturated. Unsaturated means you could add hydrogens to that double bond. So what do I mean by you can add hydrogens to that double bond? Well, let's write this line angle formula out in more of a Lewis structure showing all the carbons and hydrogens. So here we have, this is a carbon, carbon. Every carbon needs 4 bonds. This unsaturated double bond, we could add 2 hydrogens. You add 2 hydrogens to that double bond, now it becomes a saturated fatty acid. So you can take an unsaturated fatty acid, hydrogenate it, add in hydrogens to get a saturated fatty acid. This unsaturated fatty acid is called cis. It's a cis, unsaturated fatty acid, because this double bond, you are not allowed to rotate a double bond. It does not rotate in space like our single bonds rotate. The double bond is locked in this position, and these 2 hydrogens are on the same side of that double bond. These 2 carbons are on the same side of that double bond, so we call this cis, from the word cis meaning same side. Cis causes a kink in the chain, so it will bend that molecule. Cis, these 2 carbon groups of that chain, they're on the same side, and those 2 hydrogens are on the same side. Trans, those 2 hydrogens are on opposite sides, and the carbon groups are on opposite sides. So cis, unsaturated fatty acid, so fatty and then carboxylic acid, has the hydrogens on the same side as that double bond. So this fatty acid is an unsaturated. It's mono-unsaturated because there's only one double bond. So it's a mono-unsaturated cis fatty acid. Fatty group here, carboxylic acid group here. So this is a cis unsaturated fatty acid. Now let's look at this third fatty acid. We see that we've got one double bond, so it's mono-unsaturated, fatty, and then acid. So it's a mono-unsaturated fatty acid. And is it cis or is it trans? Well, remember that this just represents a carbon. Here's a carbon. The hydrogens go where there's space for that hydrogen to go. So we see that this hydrogen is opposite this hydrogen. Since they are opposite, this is a trans unsaturated fatty acid. Trans unsaturated fatty acids are the product of incomplete hydrogenation of unsaturated fatty acids and oils. So this compound right here, this is oleic acid. This is the fatty acid that you'll find in olive oil, and it can be hydrogenated to form a saturated fatty acid. That saturated fatty acid has all the hydrogens it can hold, and it's going to be a lot more stable to going rancid. It's not going to go rancid as well, and so it's going to be more stable to oxidation. So when people hydrogenate unsaturated fatty acids, sometimes you won't only get this saturated product, you'll also get this trans unsaturated fatty acids. So that's what they're talking about on the news when you're hearing avoid trans unsaturated fatty acid. Have a representation of a hypothetical fat molecule that you would find in that bucket of lard or Crisco, where if you either put it in acid or in a base, then we can hydrolyze these three ester groups. So an ester group is just a carbonyl with an O bonded to two other R groups on either side. So we've got 1, 2, 3 ester groups that we can hydrolyze, and hydrolyze just means split apart or lyse with water. So this fat molecule, we could put in sodium hydroxide, lye, to get glycerol and 3 fatty acids. So this is the glycerol molecule, also called glycerin. 3 carbons and 3 OH hydroxyl groups. So anywhere you see OH, these are hydroxyl groups. Hydroxyl groups, OH groups, make it an alcohol. That's where the OL comes from, because of the alcohol. Here we have a primary alcohol because this hydroxyl group is bonded to a carbon that is bonded to one other carbon. So this is a primary alcohol, this is a primary alcohol. It's bonded to a carbon that's bonded to one other carbon. This center hydroxyl group on this glycerol molecule is bonded to a carbon that's bonded to 2 carbons, so that's called a secondary alcohol. So when you hear that a fat molecule has a glycerol backbone, that's what they mean, that if you have this fat molecule where you have a glycerol backbone with 3 fatty acid chains,